Okay, so today I went to my stores downstairs and I went in checking for some old garbage that I basically accumulated over the years, and I found this baby. It's a Wings PC computer from the Pentium 4 era. I can't exactly remember the exact number of years during which these Pentium 4 computers were being sold, but I guess it's from around probably 2004, 2005, 2006, somewhere from around that era. It has all the necessary input and output connectors and all the necessary mass media and storage drives. Basically, there are two USBs on the front panel with the audio connectors, and you even have a floppy drive here, which is really cool. I don't have a floppy drive in any of my computers currently, and I might be needing a floppy drive for my future projects where I will be trying to revive some very antique computer hardware, which I've also accumulated. I'll get to that later. Currently I'm just focusing on this machine right now because I'm going to make this machine into an I/O rig, input-output rig, which means that I will be making this into such a machine that it has a lot of slots for 3.5 inch discs, a lot of slots for 2.5, 2.25 or 5.25 inch discs and other media. So I can just swap in and out all kind of discs and use it as a kind of a machine where I can check whether a disk is functional, etc., etc., etc. So probably I will be installing Linux on it anyway. So let's see. Let's see the insides. So here's what it looks like in the inside. Probably I'm never going to close the side panel here because it's more useful if it's open 24/7, and it's cooler that way. Yeah. As you can see, the chassis of this Pentium 4 era, around 2005, 2004, whatever, 2004 onwards actually, these older chassis, they had no idea of cable management, no idea whatsoever. All these cables, they just dangle all around, and if you happen to move the computer a bit, these cables might hit the fan and horrible things happen. So I have to solve that later with a few of these clips that I can use to bundle together some of these wires. But currently what we have here is two 512 megabyte memory modules, 1 gigabyte each. I mean 1 gigabyte in total, and then we have the DVD drive and an IDE hard disk. The IDE hard disk is disconnected because I won't be booting up the operating system installed therein, because I will be just making a few hardware tests to see if this works properly. The first hardware test I'm going to engage with this machine is the memory test, because these memory modules were scrounged from another chassis and I'm not 100% sure if these are stable or working. Actually, one of these is 266 megahertz and one of these modules is 333 megahertz. So the chipset might actually throw dice to figure out which clock speed it's going to use with these specific memory modules. And if the clock speed it chooses is, for example, 333 megahertz, which is higher than the one of the modules actually supports, there might be some problems like corrupted memory, which entails from too high a access speed. And this is why we have to run the memory test. Alright, so next thing we have to see is the system properties, see what kind of VHS this thing supports. Let's see. Okay, so here we have the BIOS setup screen for the Wings PC. I'm trying to zoom it in. Okay, you should be seeing it now. So here's the main dashboard, so to speak. It shows that it has the Pentium 4 processor speed of 3 GHz, 800 MHz system bus. That is pretty good for a computer of this age. Means that, yeah, it can do some light loads, nothing very heavy, but it's tolerable. If you're going to do just disk input output, that 800 MHz system bus speed should be enough. Now, as you can see, a system memory speed there is, it has chosen the memory speed to be 333 MHz. Now, I'm very skeptical of this, because the second module there had a sticker in it which specified that the module is to be driven with the memory clock speed of 266 MHz. So this means that this is over what? It's around over 60 MHz faster than what the second module supports. So there might be some problems with it, especially since I installed them in similar colored slots, so they have the dual channel arrangements. And if you use memory modules in dual channel arrangements, you know that it's very important that the memory modules can keep up with the clock speed they've been driven with. Okay, here we have all the basic configuration. There was nothing exciting here. Basically the only exciting thing here was the PCI Express configuration, which has some weird parameters like link retraining and link stability algorithm and compliance test pattern. The compliance test pattern is something that they probably run to check if a PCIe card is compliant or whatever. Link retraining, I think it has something to do with figuring out the max speed or maximum number of lanes that PCIe card uses. I don't really know, but that's what it seems to, imply. But all these options are obsolete in all modern motherboards. They are smarter. They don't need any configuration like this. I guess these options were put here because some of the PCIe cards of the time weren't really compatible with all possible hardware. So having one of these options here enabled you to use less compatible hardware or something. Basic stuff, wake up stuff. Okay, here we have the boot menu, the boot configuration. This is important, the most important thing in the whole fucking BIOS setup. So as we can see here, we have the silent boot. This basically disables the system information screen from coming up. Actually, system information screen is very, very important in a input output rig where we'll be swapping the disks in and out, because we want to see right away if the hardware detects the disk or not. So this is why we turn off the silent boot. It increases boot time for a bit, but the information is more important there. Then we have the rapid BIOS boot. It skips certain tests while booting. Yeah, like memory tests and whatever. Actually, I will be enabling this because I want all tests enabled, especially since I will be using this as a sort of a tool computer. Scan user flash area. User binaries. Shit. I have no idea whether I should disable this. Let's leave it enabled. Okay, USB boot. Now this is very important. It means that if I attach a USB storage unit in one of the USB ports, USB stick, flash stick, whatever, it should be able to boot from the stick if it has a compatible booting scheme, like a basic MBit scheme. Yeah, so I can boot a memory test from it, which means that now I will have to go and prepare a boot disk with a memory test program in it. Just a minute. Yes, so I went to my main rig and I actually wrote a memory test 86 image on the USB stick with an image writing program. It created there a FAT32 file system with all the files. It should be able to boot even on older machines which only support a specific form of MBR boot. We'll see how it goes. So let's boot the computer. So here we have the dashboard. We'll press F2 here to go to setup, because we need to boot from this specific disk. Oh, this is weird. Oh, there it is. So we have the USB stick in removable devices. So I will have to put the Kingston Data Traveler as first floppy drive. Weirdly enough, it's basically detected as floppy drive. Maybe the computers of this time and age didn't really make any difference between floppy drives and standalone mass storage devices. Now go to boot device priority, and from there, yes, the Kingston Data Traveler is now the first boot device. Cool. Okay, we go to exit saving changes, yes. Now we'll see how it goes. If it goes well, it should boot from the USB flash stick, and we should see the memory test program booting up. Okay, it's trying to boot. It gave some errors on reading some sectors, which is funny. Never had that before. But it still seems to be loading memtest. Oh, it started. Well, that's interesting. Even if it had some errors reading some sectors, it still started. Maybe the the USB stick there is somehow a bit broken. Although it shouldn't be, because the program that I used to write the image on it actually verified that each byte in the memory stick was in line with the bytes in the image file. So maybe that's just some error that is caused by the BIOS firmware boot system or something. I don't know. As we can see, the machines of this era were, well, not very fast in regards to memory bandwidth. You can see that the approximate memory bandwidth is just over 1.6 gigabytes per second. That's not very much, because these days you can even have strived SSD arrangement, mass storage arrangements that can beat the 1.6 gigabytes per second in linear read mode, probably. So yeah, this computer is not very fast, but it doesn't need to be though. So this test will test the entire 1024 megabytes memory blocks, and if it sees any errors, it will report them. The reason why I want to run this test is because I'm very skeptical whether the second memory module is able to run at 333 megahertz memory clock, because the specified speed for the memory module is 266 megahertz. If this test goes through, then we can be sure that it runs fine with that sort of speed. So next I'll report back after this test is done. Okay, so the memory test is complete. No errors. That means that the memory module which has specified speed lower than the first memory module was able to handle the 333 megahertz memory clock speed. I am very impressed and very happy. This means that I don't have to go scrounging around the computer stores for a very expensive DDR RAM. Because yes, this Pentium 4 machine, it uses the DDR1 memory module type, which is getting very scarce these days. The prices are very high compared to how much you actually get. So I'm very happy. The next thing that I'm going to attempt with this computer is to install some operating system on it. First, I think I said I would be installing Linux, but now that I'm thinking, this computer might actually be able to run FreeBSD just as well, because the hardware itself is pretty old. FreeBSD basically supports every chip in it. And FreeBSD, if you get it running, is a very robust Unix-like operating system that I have extensive knowledge of. And because of how FreeBSD is designed, it's just basically a shell-based, it's just a base system with basic shell utilities and stuff like that. You don't even need a graphical user interface in it if you don't want to. It doesn't force you into any specific mode of operation. So with a machine that has only 1 gigabyte of RAM, that might be actually a very big boon. Of course, you could also install dev1 into it on the minimal install mode or Ubuntu server or whatever, but FreeBSD in all its simplicity in this case is more desirable. So I have to now think how I'm going to make the video about installing FreeBSD on this. Probably I'll just document the the basic installation of the bootable root file system, and then after I get that set up and get an SSHD remote set up on it, I will just take screen caps via Windows on the operation and configuration. Anyway, and that's about it now. That's about for it. So I'll see how this project goes later.